Okay, so we want to look at the assembler now. How does it work? So the assembler is a program, and it takes input from your assembly language program which you create, and it puts out the object file, which is what you execute. It's machine code, and it also puts out a symbol table and some other files, so the assembly program is a text file you create. Has directives, macros, and assembly instructions and comments. The assembler is the program that translates that into machine code, and an object or an assembler outputs an object file, which along with the symbol table can be made into the actual code that you execute. Those two are used by the linker. So the assembler symbol table is output and is input to the linker program. Okay, so let's look at an actual assembly program and look at the coding format here. So we have over on the left the labels, and they start in the first column. They're case sensitive, and you can or optionally put a colon at the end. That's kind of customary. Then the next column are the operations. You're familiar with these. And on the top there are operations that start with a dot, or actually assembler directives. They're commands for the assembler program to do something. So it's, when you say delay.equ0, you're basically saying delay is a variable that I want to set equal to 0 to start out with. And .c declares is a directive that allows you to insert a C header program into your assembly program. In that MSP430.h, things like pwonder and these watchdog registers are all defined. All these things are defined in that file right there. You begin writing your assembly code after the .text directive, and the instructions are in lowercase and macros are in uppercase, and you end your assembly program with a .end directive. This section, this column here, are the operands, and this column over here are the comments. So let's look at symbols and labels. Symbols. The symbols are name-value pairs that are stored in a symbol table. A symbol is a string of up to 200 alphanumeric characters. You can use caps or lowercase and a bunch of things, but you cannot have blanks. It's case sensitive, and the first letter cannot be a number. A symbol value is a label, or it could be a constant or a substitution value. Basically, they're kind of shorthand things to make the program easier to read in the assembly. But when it goes to machine code, it actually has to go to values. Symbols are used as labels. Become symbolic addresses that are associated with locations in the program. So labels are actually symbols for addresses. So labels are symbols, as we said, and they begin in column 1, and they're optionally followed by a colon, and the value of the label is the current value of the location counter, or basically the address within the program. A label on a line by itself is a valid statement. Labels used locally within a file must be unique. So let's look at the mnemonics and operands section of the assembly file. The mnemonic field cannot start in column 1. It's interpreted as a label if it does. The mnemonic field contains one of the following items: an MSP430 instruction mnemonic, like add, move, jump, or whatever. An assembler directive like a dot instruction, dot data, dot list, dot EQU, dot C declares, whatever. An macro directive, dot macro, dot var, dot m exit. A macro invocation, and the operand field. The operand field follows the mnemonic field and optionally contains one or more operands. An operand may consist of symbols, constants, expressions. Operands are separated with commas. Now let's look at constants and expressions. Constants are maintained internally as 32-bit signed, 2's complement, or unsigned numbers. Constants are not sign extended. The pound sign immediately precedes a constant as in an instruction. That means the immediate sign, the number sign we've been using. Decimal digits ranging from this really big negative number to a really big positive number. That's how many you can go in 32 bits, basically. Hexadecimal numbers. They can be hexadecimal constants. You can either follow it by an H or precede it by a 0x. Binary, you can have binary constants. You can use it for have a suffix capital B or little b. So you can see how that would be. And an expression is a constant, a symbol, or a series of constants and symbols separated by arithmetic operators that evaluates to a single 32-bit number. And there's your numbers, the range for signed values or for unsigned values. So let's look at assembler directives. Assembly directives are used for creating symbol tables. That's the .equ, the .set, .c declares. They're used to select assembler sections like .text and so on. That tells you it's the where the code is coming and so on. There's some other kinds of sections. They're used to define values for memory locations. You can use .byte, .word, .string to define those. You can specify the end of the program, .end. So if you look at here is some examples in an actual assembly program. And those are all directives, notice, that you have there. And the $sign is the current location. So basically $$ means just loop forever. So let's look at some style guidelines. So it's good if you provide a program header with your name, date, etc., and the purpose of the program. You start labels, opcode, operands, and comment lines in the same column for each line, unless the entire line is a comment. Use comments to explain what each register does. Use labels, and symbols are case sensitive. Use meaningful symbolic names, mixed upper and lower case for readability. For example, ASCII to binary, input routine, save R1. Provide comments between program sections. Each line must fit on the page, no wraparound or truncations. So here's a quiz for you. I'll let you pause your video here and do this quiz.